This is Calculus 12, Chapter 3.3. We're going to be looking at the rules for differentiation. The derivative of a constant function is always zero because a constant function just goes horizontal. So the slope is always zero. Rule 2. This rule you will be using a lot. It's the power rule for positive integer powers of x. If we have f of x is defined as x to the power of n, then the rule is n times x to the power of n minus 1. It's a simple rule, but practice it to make sure you don't make errors on your numbers. Okay, so the exponent comes out front, and we reduce the exponent by 1. Here's an example, x to the power of 4. The derivative is 4x cubed. 4 comes out front, and we reduce the power by 1. The constant multiplier rule. If we have a function cx, then f prime of x equals c. And here's an example, f prime of x equals 7. So if you look at a linear function, the slope is always the same. The sum and difference rule is what you would expect. We just take the derivative of f and add to the derivative of g. So derivative of h is the derivative of x plus or minus the derivative of g. So if we look at this one, so we just take the derivative of this, 3x squared, minus the derivative of this. We're using two rules. We're using constant multiplier, and we have to use the power rule. So that's 2 times 4, that's 8. Reduce the power by 1, and we're just left with x. The product rule, this one's a little bit more difficult. So if h is f of x times g of x, then the derivative of h of x is f times the derivative of g of x plus the derivative of f times g of x. Now, it's easy to multiply these and then just use the power rule, but if you're asked to use the product rule, you have to use the product rule. And you're doing this because you're practicing using the rules, but you can verify by just multiplying these together and taking the derivative. So h prime of x equals f of x, that's x cubed, and g prime. So again, we've already done that derivative here. That's 8x times 8x plus the derivative of f, that's 3x squared, times g, that's 4x squared. Now we can simplify 8x to the power of 4 plus 12x to the power of 4. That gives us 20x to the power of 4. Okay, let's combine these two together. We get 4x to the power of 5. So h prime of x equals 4 times 5, that's 20, and reduce the power by 1. We get the same answer, and that's the way to verify it. Again, use the product rule if you're asked to. Do not try to simplify first. But if you're not asked to, go ahead and simplify first, and that reduces errors. We have the same thing with the quotient rule. Again, you can divide this out and do the simple formula. But if you're asked to use the quotient rule, please do this work. Okay, so this is, again, slightly more complicated than the multiplication rule. We have the derivative of f times g minus f times the derivative of g all over g squared. So h prime equals f prime. That's 3 times 4, that's 12x squared, times g of x, that's 7x squared, minus f, that's 4x cubed, and the derivative of g is 14x, all over 7x squared, squared, squared. And we have simplification here. This is 84, x to the power of 4, minus 56, x to the power of 4, over 49, x to the power of 4. And we have 28, x to the power of 4, over 49, x to the power of 4. We cancel out the x to the power of 4. 28 and 49 has a common factor of 7, so that's 4 over 7. Okay, let's look at this simplification. We get 4 over 7x. So h prime of x equals 4 over 7. This is much simpler, and you can do this if you're not asked to use the quotient rule. Again, polynomials are easy, but when you're doing trig or exponentials, you can't make this simplification and you'll have to go through this work. So get used to doing it now. And the power rule for negative integer powers of x. So if we have this such that n does not equal 0, then f prime of x equals n times x to the power of n minus 1. This is essentially the same rule. So we have this rewritten, x to the power of negative 3. Then we just use the power rule, f prime of x equals negative 3, and we decrease the power by 1. And you can also rewrite this as negative 3 over x to the power of 4. So we can also take derivatives of derivatives, and these are called higher order derivatives. And we've been doing the first order derivative, but if we take the derivative again, it's called the second derivative. And successive derivatives are called third and fourth, etc. For example, take x to the power of 7. First derivative, 7x to the power of 6. Second derivative, 7 times 6 is 42. Decrease the power by 1. Third derivative, 42 times 5, that's 210. Decrease the power. Now for the higher ones, we just use the number. 210 times 4 is 840. Decrease the power. And one more time. 840 times 3, that's 2520. Decrease the power by 1. And dot, dot, dot. Question is, how many more non-trivial derivatives can we take? Well, if we take the derivative one more time, it'll be x. It'll be a linear derivative. Take the derivative again, it'll be constant. So we can take 2 more. And if we take the derivative of the constant, it's going to be 0, and that's a trivial derivative. Okay, let's look at a different type of problem. This is actually relatively easy, but people forget. You're given the derivatives here at a certain x value. You don't need to know the function, but you do need the rules. Okay, so we're going to find the values of the following derivatives at x equals 2. So this is saying take the derivative of a product. So this means we need du dx times v plus u dv dx. Another way of writing this is u prime v plus uv prime. And now we can substitute. So u prime is here, -4. V is 1 plus u is 3. V prime is 2. So we have -4 plus 6, and our answer is 2. B, we're looking at taking the derivative of a quotient. So we need u prime v minus u v prime and v squared. We had f and g, but you can substitute u and v. So again, u prime, always look it up, -4, v, 1. If you look it up, you're less likely to make a mistake. U, that's 3. V prime, that's 2. And it's v squared, so we have to take 1 squared. And we have -4 and -6, so that's -10. C, now we're taking the derivative of v over u. So we just reverse this. V prime u minus vu prime over u squared. Okay, v prime, 2, u is 3, v is 1, and u prime is -4. All over u squared, so that's 3. We have 6 plus 4, that's 10 over 9. Last one. It's a long one, but that's not a problem. This is just a constant multiplier, this is a constant multiplier, and this is the product. So we have 3 du dx minus 2 dv dx plus 2, and what are we going to do here? We have the derivative of u times v in part A, so let's just use that, 2. So we have 3 times du dx, that's u prime, so -4, minus 2 dv dx, that's v prime, that's 2, and we have plus 4. So we have -12, -4, that's -16, plus 4 is -12. And just make a note from part A. Don't just put in a number, explain where you got it from so people can follow your logic. And that completes this lesson.